Okay. Okay, hello everyone. I'm Doug Kreisen. I'd like to welcome you to our Confluent and MongoDB webinar. We have a very exciting and informative session planned for you. Today, we'll be learning how to enable real-time fraud detection to prevent fraudulent transactions before they occur. We'll be talking about how to curate and integrate data in real time to dynamically create threat scores and catch anomalies as they occur. And then we'll also be showing you how to identify abnormal patterns and automate critical real-time responses. As I mentioned just a moment ago, we'll be recording this webinar for those of you who would like to share today's presentation with colleagues. And with that, I would like to introduce two presenters we have today from Confluent and MongoDB. We have Pugh-Jones. Peter is Confluent's Director of Financial Services. And we have Shiv, Pullepu, who is the Principal for MongoDB's Financial Services Industry Solutions. And here is our agenda for today. We'll start with looking at some market perspectives of fraud and what this all means for your business. Then we'll discuss how current fraud detection approaches can be improved upon. And then we'll take a look at a fraud maturity model. And this will be very interesting. So you can see exactly where you and your organization are on the curve. And then we'll explain how Confluent and MongoDB can help you throughout the entire value chain. And that's really important, knowing that Confluent and MongoDB are there every step of the way. And then that will be followed with some customer examples, our technical architecture, and a live demo with Q&A. If you have questions, you can use the Q&A button at the bottom of your Zoom window, and we'll either answer those through Zoom, or at the very end, we'll be able to answer those live as well if we're not able to do it during the session. And with that, I'd like to go ahead and turn it over to Shiv. Shiv, over to you.
Yes, Doug, thank you, Doug. Hello, everyone. My name is Shiv Pullepu. Like as Doug said, I'm a principal financial services industry at MongoDB. So what are we going to talk today is about fraud prevention. Fraud is a big challenge to businesses and consumers alike. What you can see here on this slide is based on the Nielsen report. This is just a statistics from 2020. Organizations lost almost $20 billion, more than $25 billion. If you look at last year's statistics, we lost around, we meaning businesses and consumers alike, lost around $30+ billion on just a fraud. So fraud is a very broad topic. I mean, it even starts with the account enrollment to like account closure, right? And as you can see on the right-hand side, you have identity theft and Ponzi scheme and things of that nature. I'm not going to talk about the Ponzi scheme, how we can actually prevent somebody like Bernie Madoff to actually stop doing a Ponzi schemes, but we do actually wanted to talk about card fraud, how you can use amazing technologies like MongoDB and Confluent, in addition to AI/ML power to address the card fraud. Next slide, please.
So hi, everyone. I'm Pugh-Jones. As Doug said, nice to be with you today. We thought we'd pop this slide in just to give people a recent view. Really due to COVID, the activity in the fraudulent space during that time has gone up massively. And although that's just one article, there are many on the web you can find. And the general consensus is, even though not all these numbers are always visible for all the businesses that get affected by fraud, that essentially every single dollar of fraud will now cost the industry, the financial services industry, around $4 in expenses and costs associated with it. That is, it's an astronomical number. And also, because we don't know the full extent of the real numbers for fraudulent activity, around the world. I mean, in the end, you don't really want to hear the news that your bank that you've put your money with or your financial services partner that you're utilizing has been defrauded in a massive way. So in many cases, they try to keep that data a little bit quieter. They don't want to release it all. So we do know it's a massive problem, but it's definitely been getting worse. And as Shiv pointed out, the numbers were bad enough before COVID, right? So you can see that it is definitely something that everyone's turning their attention to today. Doug, if you want to pop over to the next one. So before we go and have a little bit of an exploration of some of the use cases that we see in the industry across the different parts of the industry, we thought we'd ask you this question. Are you able to either detect or predict fraudulent activity or transactions in real time as they occur? Assuming, of course, you are someone in a banking scenario or in a situation where you're looking at data for transactions and activities like that. It'll be interesting to see what folks say here. I don't know, Shiv, if you've had much experience of asking folks that question yourself in the field, but I get very interesting replies back from folks in the banking industry who are usually responsible for some of this stuff. Things that, you know, often it's the case that they struggle to be able to do that in a way that's of value to them at the moment. But I don't know if you've had that experience as well, Shiv.
No, yes, I do. Although of all these customers I talk to, they do have some tooling in place, but they continue to kind of strengthen the existing tooling to kind of increase the fraud detection accuracy, right? So yeah, there's a lot of room for improvement there.
Yeah, one of the challenges can be lots and lots of messages being generated, false positives and false negatives as well. And obviously one of the things you can do with some of the approaches we're going to look at, hopefully today, could help reduce some of that. I don't know how long we're going to wait to see the results of that one.
I think I can go ahead and close the poll now.
Okie doke. Great.
I think we've got enough responses here, and let me share the results.
Okay. Well, okay, so that's okay. That's quite a few folks in the not sure bracket, which is great because that means hopefully you're in the right webinar, right?
That's correct. Absolutely.
Excellent. There was quite a few no's as well, I noticed there as well. So that's good. So typically when we go out and find our experience as a company of fraudulent activity as a company tends to be what our customers talk to us about. All around the world, we work with lots of different businesses, and I'm sure it's the same for Shiv as well, who talk about the sort of stories that they experience internally. We can't always talk about all of those, but obviously if you just go and look on your news apps, pretty much every day of the week, you're going to see something about a fraudulent case that's in the news, either a huge amount of activity in a particular bank that's been compromised, or often it's the case that there's some other activity that has actually been stealthily happening in the background that people haven't noticed. I thought I'd just pick one that is very current in the sort of in the news today. Certainly here in Europe, anyway. It may not be everywhere. And it's called QR code fraud. QR codes are, as I'm sure you're aware, those little codes that pop up either on screens or perhaps in restaurants, which allow you to quickly go to websites or apps to pay bills. And in the case of the UK, there's been an activity in that space in parking meters. So when you go to car parks in the UK, right now there's a QR code stuck on the actual meter, so you can click, you can take a picture of it, go to the link, and pay to park your car. And obviously, every single time we try to do something to make life easier for people, what tends to happen is that someone finds a way to exploit that. And sure enough, QR codes are now the way that people are looking to exploit and defraud. So how does that happen? How does that happen? They take a QR code of their own making. It points to a link of a website or app that they've created for themselves that looks just like the real thing. And they go to the car park and they stick the QR code over the one that's there. And most unsuspecting victims will take that code, think they're on the right place, pay the car park, and then go off and do their shopping and come back and find they've got a clamp on their car because unfortunately nobody really paid the proper company. Shiv, I don't know if you've got any other examples you'd like to raise on that sort of front.
Yeah, sure. Yeah, I do. Folks, I have actually supported a AML KYC business groups in the big financial institutions for a number of years. Before joining MongoDB. So one experience I personally had working with the banks was that fraudsters, right, they generally sign up for business accounts, like deposit account, say, for example, $5,000 per monthly deposits or so. But in a few months, the deposits typically escalate to millions of dollars. And then they swiftly or quickly transferred to different accounts. In most of these cases, these accounts are, bad actors or maybe financing, terrorist financing and things of that nature, right? So banks, they do actually prevent or detect such fraudulent transactions. But the nature of the nature of manual processes and the technology stack they use, like inferior technology stack and all that, kind of cause a significant delays in taking action. In other words, reporting such incidents to like financial crime authorities, especially in the U.S. FinCEN, right? If there is a delay in reporting such fraudulent activities, they end up actually paying a lot of financial or regulatory fines. That's what you see on this screen here, Santander. I think, I suppose I haven't actually read that story completely. Maybe one of those reasons why maybe if there is a delay in reporting such incidents, they pay a lot of legal fines there. So when you think about that, this is something we're going to talk about just quickly. There are a number of things that you can do in that area. Like one is that a sign-up process, or you need to actually do like a due diligence to create these merchant accounts or small business accounts. There should be controls there. And also need to be like a real-time processing. The transaction processing need to be done in a real time in the moment. And also they need to address a lot of these manual processes in actually that they use typically to report such incidents to financial or FinServ or SEC type of regulatory authorities. Take a pause there, and then next slide, please. Yep.
Yeah, so really along the lines of what we've said, I mean, to add weight and to just give you use cases, I mean, there are many, right? And in fact, we with so many, we ran out of space on this page, but we've captured most of the ones that people do discuss with us as a company, and I'm sure it's in the same space for yourself as well, Shiv, across a broad range. It's not just financial services, right? It could be retail, it could be anyone who has to process payments in some shape or form, either digitally. It is quite often digital, but there can be other avenues that people need help with as well. But the common thing that both Shiv and I have been talking about and are leading towards is the fact that in the end, in order to try and make a difference, a really big difference, it is about thinking about moving where you're going to do the analysis earlier on, if you can, into the life cycle of the data, in the stream, in the moment, if possible. And there are some things that we can show you, hopefully, in the next bit that will give you some ideas of the sorts of things you can do. So before we do that, we do have to outline some challenges that we know people face, right? Often the kinds of things that we want to look at data-wise to help combat fraud in the moment, in the stream, requires joining together of information that sometimes in many institutions is not always available. For example, if an investigations team needs to investigate a transaction that has been, for whatever reason, flagged by a system to say, hey, this might be fraudulent, often they don't get the full context of why that was flagged. Because the information or the metadata that said that didn't come with the actual transaction, or not much of it did. They may have a completely out of context decision to make, and often that's the case that they have some sort of SLA, some sort of requirement to make a decision, make a judgment call within a very short frame of time. So it's usually about 20 minutes. Something like that. And if they can't make a decision that says, oh, this looks fraudulent, we need to stop it, they have to allow it to continue. It may not be 20 minutes. They may have very different numbers across different financial services. Collaboration within an organization, siloed effectively ways of doing things. We often advocate for the usage of cyber type data in conjunction with the use of fraudulent data. And actually, that can be a little tricky to do, and it can be tricky to arrange those things. It's one of the reasons why something like a data streaming platform combined with MongoDB, so Confluent and that together, can help provide you with those new enrichments that you might not have been able to get in the stream before. And then you've got obviously the big obvious problem. If you wait till the data has reached a data lake to make a decision as to whether something might be fraudulent or not, it's probably too late, right? So you have to try and get in earlier than that, in the stream, in the moment, if you can, as the transactions are running. And then, of course, often the case, you might find that the level of sophistication within a business, the maturity, we're going to talk about maturity curves for combating fraud, It may be that there's just a long way to go before you can get to the stage that you can do that. But we'll talk about that as well in the journey that some of our customers have been on. Don't know if you wanted to add anything to that, Shiv. Sorry, I should have offered you the opportunity.
No, please continue, Pete.
Okay. So I've already highlighted a few things. I said often the case is that if you can combine data sources together that you might not normally have access to help you make better decisions or more qualified insights gathering, well, those sorts of things are, let's pick a few, right? If I am on an app on my phone, and I'm connected to my banking app, and we'll show you examples of that a little bit later. The way I hold my phone is something that banking app can actually track, behavioral information. Where I'm connecting from, typically, the sort of places in the world that I might be normally when I do my banking. What time of day is it in that part of the world, or what time of day do I normally do things? So patterns that we can understand, right? A little bit like, analytics, we're saying this is normal behavior, and the more information we can gather together for people's normal behavior, setting a baseline if you like, then the more obvious things that outline behavior become. So if I'm in the US and I spend some money on my bank card, and 2 minutes later I suddenly am somewhere else in the world spending money on my bank card, well, obviously that's a pattern we'd love to know. But if you wait till later to find that out, you'd never have seen it until later on, right? It's a pretty obvious statement. I don't know if there's any additional ones you would add to that, Shiv.
No, well, I do want to add something here, Pete. Speaking about finding fraud patterns, which is a key in combating fraud. Here, I want to actually share my personal experience. I was a victim of a check fraud. This is back in 2016. I was running my own consulting firm. I wrote a check for a graphics designer. He's a subcontractor. I outsourced a part of my work to this graphic design company. Initially, I wrote a check for $500, right? And a few days later, I discovered the exact same check was clear, but for a different merchant, under a different merchant, for an insanely high amount, $15,000 in this case. So, but luckily, I had to the Chase. The bank was a Chase bank, and the bank, after working with them for a couple of weeks almost, they reimbursed my money. But that left me like a very bad customer experience. Part of the reason was that they had to close my existing account and create a new account. So this was like, we're talking about 2016 when AIML was not so, well used or adopted in the banks and all that. But these days, like such a fraudulent, check fraudulent checks and things of that nature, right? Where human eye cannot detect, AIML models can actually quickly kind of find those patterns, right? So using a niche technology, a latest technology is a key in preventing a fraud.
That's a very good. Actually that must have been horrendous. I did think for a moment though. For those on the call who aren't familiar with the term, a check is a piece of paper, right? That with a piece with money written on it. I just mention it because in some parts of the world people hardly use them at all anymore, right? but you can still be defrauded on transactions like that now, which is a real problem. I mean, I've had friends that have made a payment in, say, getting out of a taxi, and it looked like it was one number, and then a few minutes later there was a second charge that went immediately through for a lot larger amount, and that from the same taxi. So those kinds of things. Also till registers in gas stations, that sort of thing can happen too, right? So it's basically the same thing, but done in the more electronic world today, right? So the problem is still there even without the physical checks, I guess. Shiv, would you say it's the same sort of thing?
Yeah, exactly. Yeah. I agree with you on that.
Yeah. So we talked about, we were going to talk about maturity curve, and we asked that question a little bit earlier to see where you thought you might be. Well, in order to help with that, we've put this together, which is really a way for us to identify when we talk to our customers where they think they might be and where also we think they might be. And also we can look at where they might want to get to in their ability to combat fraud utilizing streaming concepts. So the purpose of this really is to say, well, where are you, right? And so a lot of folks did say that they thought they had some capability in that space, but others were unsure. So really, this is the big question that we want to ask next. And actually, you put the poll question up already now, I think. So that's great. Where would you think you might be on this chart is a good question, right? So let's have a look. So number one, that's entirely batch operated fraud detection, and for sure that's been the way that folks operated for many years. And it has some level of success, right? It allows you to retrospectively, at a period of time, maybe it's every hour, maybe it's every 20 minutes, maybe it's once a day, look at the list of all the transactions that have happened, pass those through some kind of analyses, scoring, perhaps it's risk or scoring, perhaps it's rules-based, whatever level of sophistication you have, and then come up with a report that will give you some guidance as to what amount of fraudulent activity has been happening within your systems. Obviously, that's offline. It's already happened. So you are going to be in a situation there where you're used to putting a certain amount of money aside in advance of those kinds of numbers to help you cover the costs of it if you're going to be paying it back. And it is worth mentioning, by the way, financial services companies in Europe, at the very least, over the next couple of years, are going to be having to reevaluate some of that now, because they are going to be much more responsible, or held much more responsible for paying out on those kinds of activities in certain parts of the world anyway. And that means that they have to think about combating this even more into the future. Then you've got so that's level one. And then you've got way up on the other end of the scale, level 6. So this is the sort of institution that might already be doing streaming analysis of data combined with batch capabilities they already have. So they will have built some sort of machine learning models on the batch data that they've sampled over time. Those models have been picked up and made operational. They're passing the streaming data through them, and they're getting scores out of those, as well as real scores or real-time scores on the actual transactions as they happen as well. They might be comparing those two things and making decisions much more quickly as to whether or not they want to actually, you know what, let's check. That looks like that account's been compromised, or that transaction is a compromised transaction. Let's check. Maybe let's send them a two-factor authentication message and ask them to verify it's really them before we let it go through. That actually you will already be seeing taking place in some institutions now. But again, it depends where you might be on that. The vast majority of customers we speak to, and Shiv, you can let me know what you think, are going to be somewhere in the middle of this curve, somewhere on different levels of maturity as they improve, perhaps from their legacy systems into a more event-driven architecture, into taking more advantage of some of the more modern technologies. It would be really interesting to see, having chatted for all of that length of time, Doug, what the responses are on the poll.
Sure. Let me go ahead and share the results.
Okay. So that is really revealing. So we have a few at all the different levels, which is great. But we have quite a lot at level 1. But don't worry, there's an awful lot of people at level 1, and that's okay, because they've already, that's what they've been doing for some time. But many of them will be thinking about, if they're not already thinking about, moving towards the next level of maturity that they can get to. And hopefully, as we said, we'll be looking at some of that here. Shiv, I don't know if you want to add anything to that.
No, I think the one observation I made talking to a number of customers is that they use a mixture of technologies to prevent fraud. Some legacy, some rules-based, some on-prem, some cloud. The complicated a spaghetti type of technology ecosystem to prevent fraud, in addition to data silos that you talked previously, Pete, is a challenge. And I've seen like a number of these customers are actually trying to modernize into latest technology tooling to kind of effectively combat fraud. Tech sprawl is another challenge I see here.
That's great. Thank you. So I'm okay to move on to the next one, if that's all right, Doug. Thanks.
So let me take this slide. So obviously, we clearly see organizations are actually struggling to combat fraud, right? It's just it's very clear from the fact that from 2020 to 2023, there is like a 15% uptick in the amount of money organizations lost for fraud, right? And also, the organizations are continue to actually put a lot of investment into fraud. But they're still struggling. And if you ask me why they're struggling, the main reasons, maybe top 3. Fraud is a broad and dynamic, right? It's very broad, especially when you talk about payments, and you may have in your organization, different payment trail systems, right? And getting a consolidated or a comprehensive view of a customer in one single place is very difficult. Like Pete said, like part of the reason is that because of data silos, right? That's one thing. And it's a dynamic because fraudsters are equally intelligent, right? When you put in some kind of a solution in place, and they day 2 or day 3, they may actually find a way to kind of circumvent that solution and find ways to do fraud, right? So that's another thing. Data silos, we talked about it, and there is a reason why there's data silos. I'm going to talk about that in my next slide. And it's costly. Fraud prevention is very costly because of this tech sprawl, right? Data silos, mainly due to what you see on this in the slide is like there are 2 teams here, the application teams on the left-hand side and the centralized analytics teams, right? And traditionally in the banks and financial institutions, so they are separate. I mean, they work in their own silos. I'm not saying that's bad, and I'm not saying that should be changed. Because of that structure, right? That they have their different governance processes and things like that. And in that environment, getting that data, right, a consolidated view of a data in real time is very difficult. Part of the reason is they have actually these many ETL jobs and other like a change data capture systems to kind of get this data into centralized warehouse or maybe operational data layer and things of that nature. It takes a while. And also the data scientist team, right? There is, when they have actually a new approach or a model to prevent a fraud, right? And working with the dev teams, and it is not that easy. There is that the gaps actually create these, or increase the amount of time it takes to kind of put a new change to production environment, right? And time to market is significantly more in an environment like this, in addition to data silos. If you go to the next slide, please.
One of the, just if you don't mind me adding, Shiv, you just reminded me that I remember reading a stat somewhere, and I'm sure somebody will correct me if I've got this wrong. I'm sure it's something like 70% of data science models never actually make it into production either. So for various different reasons to do with the process of going through that, which of course will always affect, it might be more than 70%, but will always affect then how well you're able to combat stuff. Because by the time you finally get it ready to go, it's no good because you got to build a new one.
Yeah, absolutely. So thank you, Pete. On this slide, what you see is what I was referring previously, technology sprawl. For prevention, they use a mixture of technologies. It's maybe something similar you may have seen in your organization. At the top, like you see on-prem solutions, right? On the bottom part of the slide, you see cloud solutions, right? They're all trying to kind of address maybe a business challenge like a fraud, but the technical sprawl that is used, right? And there are like caching solutions, and there are like log state management solutions here, and also on the right-hand side, you have a data warehousing, and you have this whole on-prem and cloud. And it's okay, but the problem is that integration of such a diverse technical ecosystem is difficult. It's not that easy, right? And also using too many technologies to prevent a fraud, you may end up actually putting too many development teams to kind of support and maintain, right? Your ongoing maintenance and support costs is too significant. And that's what like previously I was saying, like the managing a fraud prevention system is too costly because the amount of tech stack that you use to do that is not like 1 or 2 technologies here. That has to be changed. If you go to the next slide, please, Doug. So what is that we are saying here? What we are saying here is that you'll have to obviously think about creating these intelligent applications, in that you bring intelligence to your applications, right? And meaning bringing your own AI, ML, and make your applications some more smarter, or applications should actually find deep insights or find these patterns and bring those insights to your consumer or a payer on a mobile device in the moment in real time. How can we do that? If you go to next slide, please, Doug. Luckily, we have, can you please go to the previous slide, please? The way I see this is like, this is done in 3 stages. Like, please, I'm sorry. 3 stages, like, right? I mean, Next slide, please.
I think we sorry there, Shiv. I think we may have lost stage 2.
That's fine.
Somewhere.
Yeah. So at the top, you see at the top, you see on the slide you have you see 3 different stages in the prevention of a fraud. Like this is typical. Like this is a standard practice that most of the banks and other FinServ firms use. What they do is they first do a real-time scoring and transaction management using some rules-based engines and things of that nature. And then stage 2 is what you see on this screen. They use something called AIML, right? They bring their own AIML models to kind of find these complicated patterns, like the check fraud that I was saying previously, finding a forged check and things of that nature, right? And also once they do this thing in these 2 stages, the third stage is to activate these observations on client devices, right? I mean, the mobile devices and other web channels. Luckily, luckily MongoDB and Confluent together can actually help facilitate this whole journey, the fraud prevention journey, right? And where you see on this slide, Confluent actually helps stream the data. MongoDB actually does all this in-app analytics and all that. MongoDB has a tooling to actually bring your own AI/ML models. For example, on this slide, I showed Databricks. So you can actually put all the pieces together in 1 or 2 platforms. Like the beauty of this is that we are using only 3 technologies here, not 15 technologies, like Confluent, MongoDB, and Databricks, or maybe some other Snowflake type AI/ML modeling. If you go to next slide, please, Doug.
Oh, there was sorry, we go to 3. Sorry about that, Shiv.
No problem. That's fine. So in stage 3, like I said, once you have the observations are actually made and persisted in MongoDB, and you actually share those observations with your consumers in real time in the moment. So what you need there is like there are features that you need, like a change management, change capture, change data capture, or a trigger-based features that are actually native to MongoDB platform, which helps to actually kind of share these observations in real time. So Confluent helps with streaming. I'm going to show you a quick demo about this, how we have done. But like these 3 things are put together, right? I mean, if you go to the next slide, Diane. These 3 stages, right? We talked about a rules-based or a detection rules services, and the stage 1 and the stage 2 is like AIML-based prevention, and the third stage is case management. And when you put all these pieces together, and it forms a nice event-driven real-time architecture like this. Right, and in this, like I said, you end up using only 3 technologies, right? It is easy to manage, and your ongoing administrative cost is manageable, and you can innovate very quickly because these are modern technology platforms. So Confluent and is for streaming, and also in streaming fraud prevention. This is something Pete is going to talk about quickly. And MongoDB, and for all these data aggregation and data persistence. And on the other side, you can bring it, depending on your particular use case, you can bring your own AI and ML platform. So with these 3 solutions, you can actually create a simple architecture to combat fraud. If you go to the next slide, please, Doug. So I have a quick demo. I'm going to show you the demo. Before I show you the demo, I want to let me go through some functional navigation screens here. When you go to this demo, you log in as a payer. Say, for example, you have a mobile app for payments to all your bills, or maybe online bills, or you want to pay to a merchant. You log in, and then you go to a customer dashboard, and then from there you can create a transaction. You can kick off a transaction. If you go to next slide, please. And then what we have developed is an example solution to actually prevent fraud using a Confluent, MongoDB, and Databricks. That's what you see in the middle, the fraud detection processor. What it does is it takes the incoming transaction as they come in, and they first land in MongoDB, and MongoDB does all the orchestration to kind of classify whether the transaction is fraudulent or not. both using a Confluent and Databricks, and also in-app analytics features in MongoDB. So once the transaction is actually classified as a fraudulent, and then the transaction is actually shared with via these change stream features and the trigger features on the MongoDB on a consumer device in real time. If you go to next screen, that's a previous slide was showing a good transaction, and the same. What if for the transaction is a fraudulent? You would see a rejected payment user experience or something like this. Let me actually go to next screen, please, Doug. Maybe I'll share my screen, and yeah, let me share my screen quickly, if that's okay, to show this demo.
There you go.
Okay, let me click on this. This is what I was trying to show you. I'm not going to go over this complete demo, but I'm going to show parts of this demo. Like when you log in, we have this demo plus step-by-step instructions on how to set this up on your local environment. We have a GitHub, and link information, all other relevant information is posted on our wiki page as well. So I have those artifacts information in one of these slides towards the end. But when you log in here, like I mentioned previously, you can actually provide your user ID, password. This is your this is something a customer or a payer dashboard, a screen from here. As a payer, I could actually go to payment gateway here, and clicking on a transaction, I would pick a merchant that I want to pay to, and provide this dollar amount. This is a happy path. This is a good transaction, and when I do that, like the transaction processor behind the scene, which is running which is leveraging MongoDB, Confluent, and Databricks kind of asset. Classifies this transaction is authorized, which is good. And what if the transaction is bad? And you see a similar bad transaction user experience here. And to do this example solution, we used MongoDB. This is where you see this, like collections view. We have used 3 or 4 collections to actually work out this demo solution. And there is a one collection for persisting all merchants that we used in this demo example. And there is a transaction stream. The incoming transactions were originally processed using a Confluent stream processing, and then they actually land in MongoDB, and MongoDB does this whole orchestration, talking to an external AI/ML endpoint. That all that streaming and the orchestration is actually is done on top of MongoDB. Also, there is the future transaction future data collection that you see here. If some of you are familiar with the AI/ML, future management and the future extraction is a big step in AI/ML processing. So there is something done here, and I'm going to leave that here. And then if you go to on the Databricks side, let me show you quickly. We have used 2 workflows, one for training a model, and the other one is for actually streaming from Confluent to MongoDB. So those are the 2 workflows. Again, like as I mentioned, the clear step-by-step instructions are mentioned in our wiki. And this is an area where we have actually used Apache Spark connector to actually integrate MongoDB with the Databricks, and that is done. And this is the power of interoperability with MongoDB. When you bring in your own AI/ML platform, it's very easy to integrate with MongoDB. That really helps kind of reduce the development work. So I'm not going to go over all these deck, but this demo, this is a section showing, previous one is showing the future data. And let me actually, this is where in Databricks you can actually expose an endpoint via a REST, and that you can actually consume it from either streams within a Confluent or a Databricks, MongoDB functions code. Yeah, so let me stop sharing. So there is this example, and we have complete information on this in GitHub, and feel free to take a look at that. If you share your screen, Doug, please again.
Sure, just one.
So in the demo solution, what we were trying to demonstrate is like using 2 or 3 technologies, you can actually make these amazingly simple event-driven real-time payment processing or payment fraud prevention systems, right? And by doing that, you'll be able to reduce the tech sprawl and also increase detection accuracy, which is a significant customer experience item, right? Critical for customer experience, and you will be able to detect accurately. Otherwise, it leaves a very bad customer experience. So, yeah, please feel free to take a look at the sample code and let us know what you feel. If you go to next screen, Doug, please. Yeah. So this is the resources link I was referring to you previously, and we have a card fraud solution wiki. And I wrote a blog on this, and more information, like you can find this on the blog, and there are other resources about MongoDB and also in general financial services use cases for MongoDB. I'll take a pause here.
And I'll just mention that we will be sending out a copy of this deck to all the attendees today. So they'll have all these links on this resource slide.
Thanks, Shiv. That was excellent. I thought what I would do in my bit was just focus on a little piece of the Confluent flow. So the bit in between the app and the Databricks, while the data is in flight and inside the Confluent environment, just to give folks a sense of what the sorts of capabilities that you have there. But to do that, it's really important to have a quick look, Doug, at the next slide, so I can just give people a sense of what's in there. So although I'm only going to show you a very short version of this, as with Shiv's version, there's a version out there that you can go to on the website, and you can actually watch the full presentation, and we'll share where that is at the end. But essentially, those of you who are new to Confluent or haven't really heard too much about what is Confluent, we have this concept of data streaming in the data streaming platform, and it flows through something called topics. For those of you not familiar with the idea of topics, they are a way to look at the information at different points. Think of it as sticking your head in the stream. It's a different place in the flow, and you can create those topics by bringing together different data sources that you may already have available, but not in the stream. Bring them together, craft data products, and those data products could give you some insights, give you additional things of use as the data is in flight. So we have on this screen this concept of source data. So that could be the app, that could be log files from services, that could be something to do with the transactions lists that are coming from the app. It could also be watch lists that have been supplied for people you don't want to do business with, or regions of the world that you don't want people to be trading with, all that kind of stuff. And then you've got that processing piece in the middle. So that's the event stream processing layer. So what we're doing there is utilizing stream processing to look at the data and gather some insights that could help further enrich the information that we're sending on to things like Databricks and other analytics capabilities at the end. And then right at the bottom, we've got an ability to share out back into watch lists, which is another thing you might want to do. You might want to create new watch lists based on the activity you've seen of different people logging in and doing things that puts or maybe raises in some way their level of concern that you might have for them. And that's really all the demo shows briefly within Confluent Cloud. So if I could just steal the screen back for you for a couple of minutes from you, Doug, let me do that. And just add that little piece in. So what this is basically my very basic simulation of a proper app like the one Shiv showed you, right? Which, but it's nothing like as comprehensive. You can only do payments and transfers from here, because it's just the way that I crafted the example. And when you do that, you can only do it as certain people. So you have to pick these names here. No intention to link it to real people, I promise, even though some of those names do look like real people. And it's got some basic information. And the reason I'm showing it this way is because I want to show everyone a stream processing pipeline. So that's what this is. This is a directed graph flow. And for those of you familiar with the concept of event stream processing, it's literally topics that you flow things through, you transform them, you do things with them. You might do some ETL on them. You might join them together. So you can see here, this is customer flow at the top. This is the transaction flow at the bottom. We're merging them together. Those data, of course, are being supplied by either the apps or from the databases. And as we join them together, we're flowing them through various different analyses. Here's an event stream processing window that's saying, look at the transactions for those entities over the last 5 days is what it's actually doing. And it's saying, give me some calculation results from that. And then a bit further down, it holds the calculation results in memory, which are this table here. And that's a calculation result, which is basically, for the simplistic way of designing it here, a probability score. I call them traps in here, just because it gives me a chance to go, Admiral Akbar, it's a trap. Okay, just for anyone who has any idea what that reference is, I'll leave it for you to find out. But basically, it's a temporal risk analysis probability. For those of you who really know what it is, it's just a risk indicator. And it's a number between 0 and 1. And if it's greater than 0.5, then I'm more concerned about something happening than I might be if it's less than 0.5. So because of that, I can then go down that flow, and then finally at the end, have some kind of alerts being generated at the end of the directed graph. And that could be going into additional insights and enrichments. It could be going back to the app. It could be passed through additional analysis, all sorts of different things. Very briefly, what I'll do is just pop something into the app here. Let's pick something. Let's just pick Patrick Stewart. Maybe he's shopping on Amazon. Maybe he's in England today and he spent $9.99. Let's just pop this on messages so we can see the message get generated for that topic as it pops into the flow. And press submit. There we go. And we should see a momentarily an example pop up in there of what's been calculated. And it'll have some kind of risk score or trap score associated with him. So that transaction has a 0.111 level of risk, which means it's less than 5. Okay, it's an example. And just because I've got a moment or two left to do it, I'm going to show you that for the purposes of demonstration, I just created a way for us to stick our head in the stream and look at that information live visually. Let's be honest, nobody's going to sit there staring at this chart looking, well, I don't think they would anyway, being paid to just look at all the different risk indicators for their different customers and different entities. But of course, the idea here is you're trying to add additional ammunition to your analysis of fraudulent activity. So if you do some of that analysis in the stream and then you complement it with all the other things that you already do, as Shiv described within that flow, that entire life cycle, you can end up with a much better level of confidence around someone being fraudulent or not. And obviously what I've got here is just 4 indicators. So I'm looking at login information, frequency, and how many IP addresses they've been logging in from, which ones look like their normal locations. This is calculations based on being compromised for payments or transfers. So they have, for those of you who can't see those, that's a sort of purpley color. That's a very light blue color. That's probably the wrong description, but anyway, that's the way I see them. And to display it on here, I've just got them stacked on top of each other. You wouldn't add all these up. But what you would do is have many more than this. You'd probably have about 40 of them, and you do a bit of calculation on those 40, and the overall trap, the super trap score that you get from doing that calculation would actually be your level of confidence that someone's been compromised. Now, if there was time, I'd normally do a joke about some of these people being bad actors, but I won't do that today. I'll leave you to go and have a look at that on a recording for another time. But I thought it was important to show. I'm going to stop sharing my screen, Doug, and then we could maybe go back to the slide that you've got, if that's all right.
Okay, that sounds great. And I think half of us are Googling the quote, Admiral Akbar, it's a trap. So
good. We'll convert everybody.
When with the Patrick Stewart reference. So let me go ahead and share the screen here.
So that was really just to show folks that after this slide, we popped it in addition to this, a little slide that shows, that's one example, loosely based upon a customer that we have who showcased to us some time ago the way that they utilize us within their flow. But there's many more of them on our website. And if you go to the next slide, Doug, there will be, there we go. So these 2 links, if you click them, one takes you to the main page for financial services data streaming examples and discussions. And then within that, all the different things you might want to look at and see examples of, which are the actual use cases themselves. Hopefully, those things will arm people with further information that they can take away and look at.
Great. Okay, fantastic. Thank you, Peter. Thank you, Shiv. At this time, we'd like to take any of your questions. If you have questions, simply enter them using the Q&A button at the bottom of your screen, and we'll look at those and we'll answer those right now. And while we're waiting, I don't know, Shiv or Peter, if you've come across some common questions that people ask after going through this webinar that maybe you'd want to share with the team.
I could go first on that one if you like. So a very common question that I get asked is, okay, this sounds great. How do I go about doing it? and it does depend entirely on the company and the level of maturity they have on that curve. In fact, right? You know, where are they with their existing systems? What's their transformation path to get to event-driven streaming type concepts? But often it can also be that the best thing to do is to pick a project, pick something that is really specifically like one of them, like card fraud, as Shiv pointed out, or one specific area of your business that you'd like to improve because of the losses are much greater. And pick that as a project and it starts small and grow from there. But I'm sure, Shiv, you've got some ideas as well.
It's pretty much a similar type of ask I see from our customers, P. Like they usually ask, well, this all sounds great, and do you have an example solution, right? That's a part of the reason why we have put together an example solution. I like to call it as a solution accelerator, right? So in that, it talks about like, well, these are great tools, and how do they talk to each other, and from the integration standpoint of view, and how do we actually set up a nice, simple architecture, and also they like to actually ask us an architecture pattern or a blueprint that they can actually use as a starting point, right? For those two reasons, like I try to actually bring all these concepts and kind of execute using an example there. Yeah. So.
Yeah. Yeah, and I do have one customer that actually is worth mentioning. They had a lot of systems. They didn't want to experiment with their proper infrastructure, everything that was running right now. So actually what they did was they took the things that they know how to do in fraud investigation on static data, so data at rest. They lifted that knowledge out of that system, put it into Confluent Cloud in the stream, and put in some synthetic data and tested it that way to see whether they could take what they already knew how to do on the data at rest and experiment it on the stream and improve in some way their insight that they had earlier. And due to that, they actually decided to move forward with the project. So there's lots of examples of that out there, and especially on our websites. And I'm sure that there'll be similar on MongoDB as well.
Yeah, additionally, I see questions about data silos from most of our customers, especially in the payments and the fraud area. How do I actually create these single customer views or operational data layers and things of that nature? We have a number of best practices and the proof points on like how to actually effectively do that. Even when you have your own legacy technologies like a SQL Server, Oracle, or even mainframes, even within such a complex ecosystem, you can still use MongoDB to kind of create those customer 360 that can be a source to all these AML models as well as fraud prevention systems.
Okay, great. Okay, thank you both. Great questions, and thanks for your thoughts on that.